or something that does a service for me. All these tools are often, but not always, complemented by a way to formalize your business process, so to make sure that your rules on the way that you do things are kept. Nice BPM diagrams and rules. If something happens, then do this. If otherwise, do this other thing. Very simple. It's a rule, but applied to human processes or to tools. All these items, all these nice blocks, often have an issue in communicating between themselves. Because, for example, the software vendor of a PLM PDM solution doesn't have a rule engine, or doesn't have an FE solution, or maybe if it covers a number of things, it's not doing ERP, or any other combination. So iProd is a solution that acts like a hub in the center, in the middle of all these tools. But it's not, so it's not overlapping with functionalities that are already in place. So it's not saying, pretending to be another PLM solution or another ERP solution, but it's something that stays in the middle. And it's gathering information, scouting information, like Google with a search engine is doing. So we are searching for information in a very specific, in a very special way inside all of these tools, and mapping them to a very special body of knowledge that we have inside the iProd tool. This approach is not taking data out of the tools, but rather it's mapping data and federating data. So this means that essentially we are logically linking data that continues to stay where it is, but it's known and made aware to all the other parts of the company, using what we call a legacy data connection tool. I will go to explain a little bit this thing, because this is one of the tools that helps you out to give meaning to the data that you have in your tools. iProd then is different from the other systems because we formalize a general PDP structure and verticalize for the specific company. While normally all the other tools, when they capture this approach, are always following some kind of specific models that are implicit in the tool, like the V-model approach, the other type of development approaches that are well known. So it's more a static PDP procedure, and it's based on relational databases. While we act mainly on the modeling of the domain. We are not interested in designing databases. We are interested in giving a structure or capturing what you already do. So not imposing you to do the things in a different way or in a better way, that maybe it's a pretentious ambition, but first see what you are doing, capture what you are now doing with your specific vocabulary, not the vocabulary that we impose as a software vendor. And possibly not integrate different tools. So not force you to bind the tools at code level or at source level or at web service level, but rather map and federate the data sources. Mapping as opposed to integration. We would like to reuse knowledge rather than having the engineer study a tick book of a quality process, and support the decisions in the PDP with your gates, your decision points, your alternatives, rather than customize an existing tool heavily to accommodate your specific things. So it's not like buying a product out of the box. It's like having a glove that is tailored for your hand. And then retain this knowledge. So make sure that if somebody leaves the company, the knowledge that stays with that person is not lost as much as possible. Clearly, there is something that cannot be easily captured. Intelligence cannot be easily captured. But the decisions, the rationales, the way of working, these can be captured up to a good level and reused for the benefit of the company, rather than hunt for experienced alternatives. What iProd is providing? iProd is providing, first of all, interoperability. So capability to use different tools all together in a transparent way. This will be shown also later during a short live demo. We do provide tools to manage ontologies. I didn't want to talk about ontologies because ontology, when you start talking about ontology, people say, okay, you are in an exotic paradise and maybe you are thinking and drinking something weird. Ontologies are in effect a very simple thing, a very simple way to define the things that you are using every day and the relations between these things. It's not a lot far from this. Mediation tools, tools that help you to think on these concepts and relations and make use of this information. And then reasoning, which actually is a step ahead of the mediation, which is an automated way to retrieve or make explicit information that is not explicitly available. There are some examples later that maybe can help to make this thing clearer. And then federation tools that are not forcing you to make heavy customizations, but rather are adapting to your environment. The innovations that we bring to address the challenges that I spotted at the beginning are subjective-objective correlation. So make sure that your requirements expressed in a customer perspective are made down to the engineering quantifiable thing that engineer the quality in your products and services. Then planning and optimization. So make sure that you come up with the best possible plan that you can have, and that this plan adapts to changing conditions. It's not static and rigid, but it's flexibly adapting to changing conditions. Use what we call knowledge-based engineering, KBE, for virtual execution, which is a very powerful tool to reduce repetition of the same tasks, when these tasks can be easily done by a computer. And then we also provide ontologies, that is a map or a description of the domain for products and process representation. Part of it has been already presented yesterday, and there will be also some other presentations about these ontologies later today. Then I will say that the big improvement is in the fact that all these things can be put in a place, so that at some point you have a place where to put your knowledge, and this knowledge is not lost. So many times you think, I know this item, I know that I did things in this way, where can I store this information? And sometimes you just write up something on a paper or a notebook, but it stays there. It's not searchable, it's not retrievable, it cannot be shared easily to others. So make this information formal and part of the structure. And then, also make sure that all the computational resources that you have work for you in the best way possible. This idea starts from the bottom. So it's not requiring you to take big management decisions at CEO level. you can start with just one department and build your department knowledge. And then, little by little, you can make it work more for you, extending to more teams, more groups, more divisions, up to the higher levels. The benefits that you get clearly are on the fact that product and process knowledge formalization reduce mistakes, implements the best practices on a concrete way, not through quality manuals, and makes sure that when you take a decision, this decision is traceable. And allows you to use this very powerful paradigm, which is knowledge-based engineering, where this knowledge resides in one single place and is accessible to everybody, and can be reused as much as you want, updated, improved. And this goes from business processes at a very high level down to simulation processes where you do physical things or virtual things with testing, multidisciplinary optimization, process integration, a number of topics that we have all seen today in these days during the conference. So how to go from the high-level management tools down to earth in doing the physical things. There is a lot in between and different perspectives. Come on. It's not going ahead. Yeah. Here it is. So there is not at the moment a smooth transition from these business processes down to the simulation ones, down to earth. So I would go from a very high level view down to the very low level view. It's knowing, it's passing through the use of the knowledge, like planning the tests, correlating data and information, and then going back again with a feedback to the knowledge. So make sure that if an engineer detects at this level that something just doesn't work because it's part of your sub system and this thing is not just working, it's not fitting, for example, your components, then this thing needs to go up. It needs to be detected and step up at a higher level so that next time you don't do the same mistake. And there are tools that we have in the process in the iProd context that can handle both business processes and simulation processes. But we have a special citizen, I will say, in the iProd context, and this is the legacy data connector. That is, I will say, the tool that makes all this knowledge captured and work for the iProd framework. So the legacy data connector is a tool that actually creates what we call a semantic layer in your company's data. Another very exotic word, semantics. In effect, it's a way to give meaning, to express explicitly what you are doing with your data and what this data represents for you. So this without interfering with the data. Data stays as usual. It's not changed or touched, but it is enriched with some extra info that you know and that you can annotate, you can add to the current data. So this tool allows data to be associated with a meaning, also known as semantics if you want to, where normally your computer doesn't understand it. It's a very simple example, maybe you cannot read it from there, but if, for example, my father is called Alex, then you know that Alex at least has a son. it's implicit, because I'm saying he's my father, then means that he has a son. But when you tell it to the computer will not be able to derive this very simple fact, unless you tell him that there are relations between father and son, which are just two concepts, and the relation is fatherhood. So semantifying data means telling the computer what your data means. So when a component A has a subcomponent B, and B as a subcomponent C, then it's clear to us, but not to the computer, that C is a fragment of A. So everything that impacts A may impact also C, down 2 levels. So the more information that the computer has, the more it can derive for you. So for example, when you have a requirement and this requirement applies to a specific component, a suspension arm, a service, something, then it's clear that this requirement applies also to all the fragments of this component. So all the items or subcomponents that depend on this component. Or that, for example, if you have a requirement on a powertrain and a subcomponent of the powertrain is a motor, an engine, and then this engine has subcomponents like cylinders, pistons, etc., or crankshaft. Now you know that when you have a maximum weight constraint, this maximum weight constraint applies to the whole powertrain, including the engine, including the pistons, including crankshaft, etc. So, so if you ask the computer what requirements are relevant for the crankshaft, then it will tell you that the powertrain has a maximum weight of 200 kilograms. But without these logics, the computer would probably have told you anything, nothing. It will not be able to derive these simple things if you don't make these relations explicit, which is really not complex. It's really easy to do. So we are explaining to the computer the relevant business logic via these ontologies. And when speaking of ontologies, it's not just vocabularies. It's not just a different way to tell the things, but it's a way to express the relations and the concepts that you take care of. So in order to make all this knowledge, this hidden knowledge, explicit, evident, I'm almost done, the legacy data connector links the existing data to a central ontology, not modify it, and make it accessible for you. So what are the benefits that you can get out of this? The fact that you need to spend a little cost, and this cost is paid only once, and it's used every time, which is building a small connector for your specific tool. So you have a PLM solution, you just need to create a small connector to that PLM solution, and it's done. So the legacy data connector works with connectors, essentially, and these are the way that he knows how to retrieve the data. In this way, your data integration approach becomes much more productive, because you can derive, with the reasoner, you can derive knowledge that is implicit and make it explicit, evident, clear, immediately usable. Ontologies are also a way so that your business colleagues, or more sales colleagues or marketing colleagues, can understand much better what is happening in the engineering field and vice versa. So that you don't have fights with your marketing colleague that says that customers want a comfortable car and then you are designing a Ferrari. So ontologies makes this thing easy to understand, and help you to model your business logic, and link it to the engineering part. So at some point when you write down the things, I think that everybody made this experience, when you start writing down the things, you realize if the things that you have been thinking about are logic or are inconsistent, and then you correct, improve, and then come out with a good, well thought thing. So this helps you to reflect, improve, and also monitor what you are doing. Conclusions, very shortly. What the main challenges are for the product development process. I think that it's clear that we have knowledge-intensive processes, so knowledge management is a key element in this context. Product and process complexity, as we discussed at the beginning, heterogeneity of products and data heterogeneity of product and processes. These high-level challenges are exploded in the previous slides. I think that it's pretty clear. One of the possible solutions is not to re-engineer the existing tools, but rather use a logical approach, a knowledge management approach, to add intelligence to what you already have, give meaning to it, and reuse this meaning for you in the next versions of your products. Build your knowledge capital, little by little, and protect it from being dispersed or fragmented when people leave your company. Of course, we would like to acknowledge that this work has been possible only thanks to the support of the EC Commission, and last but not least, the hard commitment of all the partners of the consortium. Thank you.
Clear presentation. I hope everybody enjoyed, besides the iProd-Knowledge that are outsiders. Are there any questions? Myself, being an old timer, I drew a lot of parallelism from what you presented with my own experience. Back in the 80s, early 80s, when I was with the Cell Research International, there was a tendency to make production in the United States much more efficient. And the Japanese had developed such techniques, and it was proven with the Toyota lines and production lines of cars. And I remember, and they had come and they had given lectures, we got certificates that we were trained as managers. And I draw the following parallels because life remains the same. At the beginning, when you describe what goes inside the company, you mention one of the requirements is to reduce the number of late fixes. And later on in your presentation, just a few slides before the end, reduce the mistakes. It's the same thing. Reduce the mistakes for the whole process, but also part of doing something, don't make it wrong then, so it goes back to be fixed. Then we called it do it right the first time.
Yes.
That was the motto. And then you said again at the beginning, the same slide where you talked about reduce the fixes, do more with less people, with less money. And then at the very end, you indicated implement the best solution. Of course, best solution is justification what is the best. And I presume you meant, again, do a good product with the minimum cost and time.
It's indeed an evolving improvement towards the best, although the best you cannot reach in absolute ways, but it's a relative improvement.
And we used to call it then be, lean, and mean.
Right.
So that was in the early 80s, but then because PCs were just introduced, the weight was placed on the human factor, which was the management, and also all the people involved in whatever process and production was there, even research, because it applies to everything. And we're doing the human way. Now, of course, it's correct to do it with computers, so it exists and continues to exist even when people go. And even then we can start doing that, because the one thing you said, that not the knowledge to be lost when people go, is to create what we call at all times expert systems. And at that time, it was a new science. And there were people that were trained interviewers. And I remember before I moved from Houston to The Hague, I was interviewed by one of them. He had his software, and he was asking a lot of questions about the work I was doing and how I was doing it, like a patent lawyer who he's asking about the different solutions. So it's fascinating to see that the effort continues and the strive is there. Yes. And I think iProd is, at least in my mind, the way I have been trained, I have seen things happening and developing. It's a very nice project.
Hopefully removing the hassle of being interviewed for 2 hours to get your knowledge, but rather
it's been done
automatically helping you to put this knowledge in the system little by little and progressively.
And just to close, don't forget, if you want to do something fast, you have to adopt the skunk works approach, like Lockheed did to build the best fighters in the world. You get a good engineer, a good manager, a good group, you put them in the back, and you tell them to build it.
It's like having all the knowledge in one single place.
Yeah, that's all right. Anyway, I guess, well, thank you again, and you will continue.